I want to comment on a problem that occurred on the homework where you were asked for the slope of a curve of the form h of xy equals 0 at a given point. And everybody answered that question by using a formula they saw in the book, and nobody displayed any insight into the meaning of that formula. So I wanted to talk about the meaning of that formula and make another plug for understanding what's behind a formula before you use it, or when you use it. Get the right answer, certainly, then think back, why did that work? I know time is a factor, but you have to do some of that in order to get anything resembling full benefit out of this course. Okay, so why is that so? Well, that's so in terms of something that we have been over fairly extensively. Okay, so let's just think again about h of xy equals 0. That's going to give you a curve. Now there's a point on the curve and you want the slope. Well, the slope will be the slope of a tangent line. Now you can get a tangent vector. How do you get a tangent vector? Well, various ways. You can take derivatives of your x and y components and put them together and get a tangent vector. But I'm just going to talk about a little more elegant way to do this in terms of something that we should know by this point, which is that the gradient of h is perpendicular to this curve. Okay? So the gradient of h is here. It's perpendicular to the curve. It's perpendicular to the unit tangent vector. So gradient of h is hxi plus hyj. The unit tangent vector is perpendicular to that. Okay, what's a vector perpendicular to this? Well, there are two possibilities, two very simple possibilities. There are more complicated ones, but hyi minus hxj is perpendicular to hxi plus hyj. The dot product is clearly 0, and we should understand very well, because we should have done this on several problems. If you reverse the coordinates of a vector and make one of them, give one of them the opposite sign, you're going to get a vector perpendicular to the one you had. And that's just related to the fact that the slope of a line perpendicular to a given line is the negative reciprocal of the slope. Now, what does slope have to do with any of this? Well, the slope of the del h vector is what? It's the y component divided by the x component. Hy divided by hx. That's the slope of this thing. What's the negative reciprocal of that slope? Well, it's negative hx over hy, and that's why your formula works. Much better, I think, to understand the picture, understand what the gradient and the tangent are telling you, and how the gradient and the tangent are related, and the fact that the slope is very much related to the direction of the tangent. The other way to get the slope, well, the slope of the tangent vector is negative hx divided by hy. Okay? So either way, either by saying, well, it's a negative reciprocal of the slope of the gradient, which would be negative hy over negative hx over hy. The slope would be hy over hx, negative reciprocal, negative hx over hy. Or by actually getting a slope of a tangent vector and saying that, well, the slope of that vector is negative hx over hy. Okay? And I can't help but think it's important to be able to do things with formulas, and it's a non-trivial skill, and I'm not denigrating it, but it's much easier to remember this than it is to remember a formula that really conveys very little meaning about where it came from. So you want to think about this, and think about the fact that on homework you just grabbed a formula out of the book, used it, and if you don't happen to remember that formula in the test, you're done for. If you remember this scheme, you can reconstruct it.